Hello everybody, I welcome you all to NCASE Geology class. Today I will discuss on the topic that is weathering. How weathering takes place, what is the end product of weathering, what are the different processes of weathering, what are the factors that favor weathering process, and what is the end product, what is the ultimate product of weathering, that I will discuss. So let me start this topic. We know Earth crust is very dynamic. It is subject to different types of forces. The forces may originate from within the Earth's interior, which are the endogenic forces, or it may originate over the Earth's surface, which are exogenetic forces. And because of the operation of these two types of forces, the Earth's surface features are found to be modified. These forces, they bring about modification of Earth's surfacial form through different kinds of movements. It may be horizontal, it may be vertical, and through physical and chemical changes that take place over the Earth's surface. And the processes which bring about these changes are called geomorphic processes. So what is geomorphic process? Geomorphic process is defined as the process by which there occurs a modification of Earth's surfacial form through chemical, physical and biological changes brought about by endogenetic and exogenetic forces that are active on the Earth's surface or they are active from within the Earth. Endogenetic forces include earthquake, volcanism, diastrophism. Diastrophism includes orogeny and epiorogeny. And exogeneric forces include the role of geomorphic agents such as wind, running water, glacier, waves, tides, tsunamis in modification of Earth's surfacial form. So what is geomorphic agent? These are the running water, wind, glacier, they are called as the geomorphic agents. So how do you define the geomorphic agent? Geomorphic agent is defined as the mobile medium which is capable of securing and transporting earth material by which there occurs a change in configuration of the land surface. The land surface are either found to be lowered down or are found to be elevated up. So running water, wind, glacier, groundwater, waves, tides, tsunamis, they are the agents of denudation or they are the geomorphic agents. They bring about the geomorphic processes or exogeneric processes, and by those processes they try to bring about a modification of the Earth's surfacial form. Let us have an outline study of the different geomorphic processes. The geomorphic processes are divided into endogenic process, exogenic process and extraterrestrial process. In case of endogenic process, the forces they originate from Earth's interior. This includes earthquakes, volcanism and diastrophism or tectonic forces, which try to bring about building up and elevation of land surface or leveling down of the Earth surfaces. In exogeneric process, there are two processes such as degradation of land and aggradation of land. Degradation means leveling down of the land or wearing down of the relief or elevation of the land. And they are caused by all geomorphic agents such as running water, wind, glacier, groundwater, waves. Similarly, aggradation is a process where there occurs leveling up of the land, and it is also achieved by running water, wind, glacier, groundwater, waves, currents, tides, tsunamis. So what is exogeneric process? Exogeneric process operates on the surface of the earth. Exo means out, genetic means origin. Origin outside the Earth's interior, or it operates on the Earth's surface. It derives its energy from atmosphere and the sun. The exogenous processes, they derive their energy from the atmosphere, and the role of sun is there in regulating the exogenetic processes. It is influenced by the slope or gradient of the ground, which are developed by tectonic factors, because slope plays a major role in bringing about the modification of Earth's surfacial form. So slope is a factor. Then gravitational forces that tends to push material down slopes to produce stress, shear, slippage, movement, and deformation of rock layers. Because gravity is a directional force which tries to pull the rocks of the Earth's surface down slopes, and all the matters that lie over the Earth's surface are being pulled by Earth's gravity towards the center of Earth. So gravity plays a role in transfer of materials, particularly in the sloping regions. As a result of which the surfacial features of the Earth are found to be modified. Similarly, molecular stress on the rock, it is caused by change in temperature, crystallization in rock openings, solution of soluble minerals, chemical reactions that take place to lose the bond that exists between the minerals. So, these include the molecular stress in rock, as a result of which the rocks crumble to the surfacial stresses. And besides these, we have other factors such as topography, climate, vegetation, insolation, the heat received from the sun, and the rock structure and composition. All these factors together control at how or at what rate the weathering can proceed, or degradation of the land surface can proceed, or the superficial forms can be modified at what rate, that can be controlled. So these are the factors, and these factors, they cause the exogenous process to operate over the Earth's surface to bring about modification of the Earth's superficial form. These exogenous processes, they include weathering, mass wasting, erosion, transportation and deposition. These are the processes by which the exogenous forces or the geomorphic agents play their role over the Earth's surface, and they try to bring a modification of Earth's superficial form through erosion, transportation, deposition, and the weathering process that brings about the role of interaction of Earth's atmosphere with that of the lithosphere, as a result of which the crustal rocks crumble to this process and they yield granular rock fragments, and the final product of this weathering process becomes the soil. And once the loose material is produced over the Earth's surface, they are transported down slopes under the action of gravity, which is generally described as mass wasting. So weathering, mass wasting and erosion, these are the three major processes by which the Earth's superficial features are found to be modified, and that's why they together account for the exogenous processes that is operative over the earth's surface to bring about a modification of the earth's superficial form. So these processes, they bring about denudation of the earth's superficial, denudation of the earth's surface. So what is denudation? Denudation includes weathering, mass wasting, erosion, transportation of rock fragments. They together give rise to denudation. So now let us discuss weathering in detail. So weathering is a process of breaking down of rocks in their own place. So let us discuss what is weathering. It is a surface phenomenon that takes place at the interface of atmosphere with the lithosphere. It is a dominant process of soil formation. By weathering, the end product of weathering is the formation of soil and regolith. We know soil is very, very precious because it supports vegetation, life, wildlife, habitat, water, minerals, oil and gas on the earth's surface. And this process is extremely a slow process. So if you take into account what is the definition of weathering, it is simply defined as the process of breaking down of rocks in their own place, in situ or on its own site. The breaking may be mechanical, breaking may be chemical, or it may be biological. It is mostly brought about by the effects of the elements of weather and climate, and hence weathering is simply described as a weather-beaten process. It is a weather-beaten process. What are the agents of weathering? These are the atmospheric gases, temperature, pressure, water vapor, water, organisms, lightning, and crystal growth. These are the agents that bring about the degradation or that bring about breaking down of rocks in situ. And the rate of weathering or the factors that promote weathering, they are the bedrock composition, particle size and structure, climate, temperature, rainfall and groundwater level, vegetation and organic factors, soil geochemical factors, topography and time. So these are the factors that control the weathering process. Let us discuss these factors. Bedrock composition. The rock composition is a major factor that controls whether it will be affected by weathering or not. There are certain rocks which are very hard and resistant to weathering. There are certain rocks which are very weak to weathering. For example, granite, it is very resistant to weathering. Basalts, they are comparatively weak compared to granite and they yield to weathering easily compared to granite. Besides this, there are very soft rocks such as limestones, dolomites, which can break very easily through weathering process. So rock composition is a factor. Then particle size. Finer the particle size, greater is the rate of weathering, because the surface area becomes more when the rocks become fine grained. For example, if we break a big cube into many smaller cubes, the total surface area of the big cube is less than the surface area of the small cubes. So small cubes will be readily affected by weathering compared to the big cubes. Thus, the rock types which are fine in grain size, they crumble to weathering process easily compared to the rocks which are highly coarse grained. For example, basalts, they are very fine grained they weather more easily than a gabbro, because gabbro is coarse grained, basalt is fine grained. Besides this, the rock structure. Structures in the rock, they indicate the presence of weak planes such as joints, fractures, fissures, faults, foliations, folds in the rock bodies, and these are the weak planes through which weathering can proceed very easily and breaking can be accelerated along these structurally weak zones, weak planes. So massive structureless granite is more stable compared to the granite which is highly jointed. Similar climate. Hemitropical climate helps in mechanical and chemical weathering. So weathering proceeds at a rapid rate in hemitropical climate compared to the glacial climate and dry climate. Vegetation. Vegetation protects the ground from the sun rays and hence from insolation or from the heating and cooling effect of the sun rays. A bare ground faces more mechanical breaking down of rocks than the ground which is having a vegetation cover. Again, vegetation covered low-lying areas face more chemical weathering due to organic activity or due to humic acid produced by the plant materials accumulating on the ground. The soil geochemical factors such as acidity, alkalinity, oxidation reduction potential, ionic concentration, they help in loosening the bond in the minerals in a rock by which breaking of rocks become easy. Besides this, topography is the configuration. Topography plays a role in the weathering process. Topography defines the configuration of the land. It may be highland, it may be lowland, it may be sloping land. So the rate of weathering differs from highland to that of lowland, and again it differs from that of the sloping land. So topography plays a role in controlling the weathering. In highlands, the mechanical weathering becomes more compared to the lowlands where chemical and biological weathering dominates. In sloping land, there is high degree of rate of weathering compared to the land which is having a gentler slope. Because in high sloping areas the rocks are under stress and under the pull of gravity they are under the strain, and that's why they are found to yield to weathering process easily. And the last factor is time. It is known that weathering is a slow process and static process. It takes about 1000 years to produce about 1 centimeter of soil. So from this we can imagine how slow the weathering process is and how precious the soil that supports vegetation, that supports life on the face of the earth. That's why it is required that the soil cover on the land areas should be protected, because weathering, the process which yields soil, is an extremely slow process. It is not perceptible in naked eye that weathering is taking place because it is a very slow process. It slowly affects rock, leading to their disintegration and decomposition over a prolonged time. Now let us discuss what are the different types of weathering. They are physical and mechanical weathering, chemical or decompositional weathering, then biological weathering. Let us discuss what is physical weathering. Physical weathering involves breaking down of rocks in their own place, and the breaking down is mechanical. It is not a chemical breaking down of rocks. And it depends upon the overburden pressure or load pressure or the shearing stress the expansive force due to change in temperature, the expansive force due to crystal growth, and due to animal activity, plant activity, and water pressure that controls, or the water pressure controlled by wetting and drying cycles. So these processes, they cause mechanical breaking down of rocks. Rocks become granular and there occurs no change in chemistry. These forces over their prolonged and repeated operation affect the rock, leading to mechanical breaking down and production of fine rock grains and flakes of rock matter. The process includes expansion due to unloading, heating and cooling, and crystal growth. Expansion due to unloading. As we go with depth, the overlying rock pressure increases. So rocks at depth are found to be under the influence of stress or load pressure. If by some means or other the load pressure decreases, the underlying rocks expand outwards. The lowering of load pressure takes place due to erosion of the overlying rocks. It may be due to landslides or it may be due to melting of thick ice sheets from the top of the mountains, or it may be due to faulting, as a result of which the overlying load is found to be reduced. Under that condition, under the removal of load pressure, there occurs expansion of underlying rock. Due to this, fractures roughly parallel to the surface topography develops. These fractures are very closely spaced near the ground surface, and with depth, the gap between the fractures widen. The process of getting these parallel fractures is called sheeting, or these give rise to sheet joints, and these are due to expansion due to unloading. So sheeting results due to unloading of pressure or by decompression. Its effect may be felt up to a depth of 100 meters depth or more. The sheet joints develop in upwardly convex bodies such as domes with uniform composition. The rock should be of uniform composition, as is found in case of the granites. Say granite. The term exfoliation is used to represent sheet joint that resemble curved surfaces of an onion, where thin flakes of rock matter are found to get separated from the rock bodies. There it is said to be exfoliation. So sheeting is a process of breaking down of rocks of uniform composition through unloading of pressure, particularly in domal country, in domes. This type of removal of domal pressure causes formation of roughly parallel fractures parallel to the topography or parallel to the domal structures. So expansion due to unloading is a process. Next process is cooling and heating, or because of the sun rays. This process of breaking is very effective over rocks due to heating of the sun rays, and cooling due to rain or during night time. In hot climates, it is fared well. The high elevations, high altitudes face the diurnal temperature variation easily, which cause them to break mechanically. to produce rock grains. It is well known that rocks are made up of different types of minerals. These minerals have different rate of thermal expansion and contraction. Hence, continued and repeated heating and cooling of the rock's surfaces causes stress and strain on the rock surfaces, as a result of which cracks develop on the rock surfaces. It is known that rocks are bad conductors of heat. So, in a very slow rate, the heat is found to permeate into the surface layers. Hence, heating and cooling effect is only felt on the rock surface, and it is not found to permeate into the deep into the rock body. So, it exists on the rock surface in form of a very thin layer from the surface. Through expansion and contraction, cracks develop and thin flakes of rock matter are found to be separated from the rock surfaces. This process resembles peeling off of onion surfaces, and this process of breaking down of rocks or providing thin flakes of rock matter from the rock bodies is called exfoliation. Ex means out, folia means leaf-like process, or it is a process of producing leaf-like rock flakes through continuous expansion and contraction due to daily heating and cooling effect through sun rays. Mostly edges and corners of the grains are affected by heating and cooling process. First the corners are affected, then the edges are affected, finally the surface faces are affected. So the corners, they are affected well, edges, then it is because that when one side of the rock body facing the sun rays is heated up, the other side is found to be in the shade. Similarly, when the other side is found to be exposed to the sun rays, the first side goes to shade. So during daytime, all sides of a rock grain are not equally heated and cooled. Hence, cracks develop in them easily. The corners edges are destroyed first, then the surface. This leads to the rounding of the corners and edges of the rock grains, and the rock masses become more or less rounded. As a result of this, the rounded rock bodies result. The process of getting spherical bodies from angular rock grains through scaling, peeling of rock surfaces by the process of exfoliation, and the rounding of corners edges is called spheroidal weathering. So the process of converting the angular grains, angular rock masses into rounded rock masses through rounding of their corners and edges is called spheroidal weathering. Massive, well-jointed granites, gabbros, basalts weathered to produce spheroidal bodies and boulders. So the process is called, this process of getting spherical bodies from the angular masses is called spheroidal weathering. Then let us discuss what is crystal growth. Crystal may be ice crystal, it may be salt crystals. Ice crystal play a role in cold countries and salt crystals play a role in arid climatic condition, so that the rocks break under the influence of the formation of these crystals. In cold climate, water freezes to form ice and it is accompanied by a rise in volume. Volume rises by 10%. So the water contained in the cracks, let us say this is a crack. So water contained in the cracks freezes and there occurs a rise in volume, so it swells and pushes the rock mass in both sides, widening the crack. The crack has been widened. And finally, the crack widening continues to separate these two blocks have been separated. We have seen this process of frost formation in the ice stage. The ice stage show sealing of the freezing from the surface inwards. This will be containing water when the top is freezing. It has been converted into ice. Gradually ice formation continues till the last drop of water is found to be freezed. So the water finds no chance to spill away and it pushes the tray in this manner because of increase in volume. Similar thing happens in case of the cracks. If it is a crack is found to be filled up by water and freezing starts from the surface inwards. Therefore, the water will not find the chance to come out, and under that condition, the crack will widen. So, in this manner, the freezing of ice or the frost causes breaking, and the process is called frost wedging because it acts like a wedge. That's why it is called frost wedging. And beside this, frost heaving is another factor, particularly in particular water contained in the loose sediments. So what is frost heaving? Let us discuss. Water contained in the loose sediments freeze and expand. During this process, there occurs lateral and vertical shifting of rock grains layers. But in this process, bigger grains are found to gradually brought to the surface with finer grains going down and down. This process of lifting and breaking down of rocks is called frost heaving. Heaving means lifting. Frost lifts the bigger grains and bigger grains are brought to the top and smaller grains they go down, smaller grains go down. The main purpose of weathering is to break the rocks. So, coarser rock fragments that occur within a greater depth, they are brought to the surface so that it can be attacked by weathering process easily, and the fine grains they go down and down because they have reached the final stage of their breaking. They have been converted into very fine grains or soil. So soil or finer rock fragments go down and coarser rock fragments are brought to the surface, and this is brought about by formation of frost, formation of ice within the loose sediments, and this process is called frost heaving. And in case of arid climate, salt acts as an agent of weathering and it expands due to thermal action, hydration and crystallization. Many salts of calcium, sodium, magnesium, potassium, barium have the tendency to expand. Temperature variation from 30 degree to 50 degree centigrade is generally seen in deserts. This temperature favor the formation of salt. These crystals near the surface cause splitting of the individual grains in rock layers due to their expansion. Thus, grains gradually get disaggregated by the formation of salt crystals on the surface. The process is called granular foliation or granular disintegration. It is caused by the formation of salt crystals. So salt crystallizes through alternate wetting and drying conditions, and they push the neighboring grains aside. Sodium chloride and calcium sulfate, which is gypsum, their crystals heave up or lift the overlying layers, help the development of polygonal tracks over the heaved surfaces. Through salt crystals, the rock layers which are affected by breaking, they crumble to weathering easily. For example, chalks, they weather fast, followed by limestones. Then the sandstones, shale, gneisses and granites. Granites are the last rock to be affected by these crystal growths. And there are certain minerals which are found to swell on being wet. Micas, clay minerals expand on being wet. When they are brought in contact with water, they absorb water and swell. This process is called slaking. By this process, the pressure develops and disintegration of rocks are accelerated by the change in volume of these minerals when they absorb water. So, the slaking causes breaking down of rocks. So, these are the different processes by which physical weathering takes place, or rocks produce grains, and there is no chemical breaking down of rocks. But when you talk about chemical weathering, it involves breaking down of rocks into simpler and simpler components from complex composition. So let us discuss what is chemical weathering. Here the agents are the atmospheric gases such as oxygen, carbon dioxide, heat of the sun, carbon dioxide produced from the decay of organic matter, atmospheric moisture. So these are the agents that take part in chemical weathering. Water breaks to produce hydrogen ion and hydroxyl ion. This hydrogen ion, because of its very small ionic size and highly concentrated charge, it enters into the mineral structures easily because size is small and highly concentrated charge. It breaks the bonds existing in the elements. Elements are bonded, and that bonding is found to be broken by this hydrogen. As a result of which the minerals easily crumble to breaking. Easily yield to breaking. As a result of this, the minerals become weak and hence yield to breaking process easily. Besides these, there are some minerals such as nitrates, sulfates, carbonates. These are weak chlorides which are easily susceptible to chemical weathering, leaching, solution and removal because they are weak rocks. Carbon dioxide charged atmosphere in the industrial areas cause acid rain that affect the rocks through corrosion or chemical weathering, corrosion or by solution. As we see in case of limestones are converted into calcium bicarbonates through reaction with carbonic acid. So what are the different processes of chemical weathering? They are hydration, hydrolysis, carbonation, oxidation and solution. These are the common processes of chemical weathering. So what is hydration? It involves addition of water into the rocks or the minerals, they absorb water, and through this process they become weak. And this absorption of water is not involving a true chemical change because this process, this is a reversible reaction. Through hydration, the minerals undergo expansion in volume. Through dehydration, they shrink in volume. This expansion and contraction through hydration and dehydration lead to rock and mineral fracturing and breaking. For example, anhydrite, which is calcium sulfate, in presence of water it becomes gypsum, and this gypsum with heating it liberates water and it is converted into calcium sulfate. So it is not a true chemical change, but by absorbing water it becomes weak. Similarly, hematite becomes goethite on absorption of water. Similarly, hematite also becomes limonite by absorption of water. And clay minerals, they on absorbing water or they get increase in volume. They show increase in volume, they swell. And the salts through repeated hydration and dehydration, they cause stress and strain because of their volume change and volume shrinkage. So, the hydration process is not involving a true chemical change, but it because of its expansion and contraction, it affects the rock. Then hydrolysis, it represents a true chemical change. Here hydroxyl ion is being produced. Water breaks to produce hydrogen ion and hydroxyl ion. This hydrogen ion is chemically most potent, most powerful to break the bonds that exist in the minerals and cause them to weather easily. For example, orthoclase. It reacts with water to produce potassium hydroxide and aluminosilicic acid. And this aluminosilicic acid becomes unstable and it breaks to produce colloidal clay and clay minerals. Colloidal silica and clay minerals. So orthoclase is a common mineral in igneous rock. It yields to weathering process and it provides potassium hydroxide, which may on reaction with carbonic acid may be converted into potassium carbonate. So feldspars on hydrolysis, they change into clay or kaolin. So this is the reaction in which kaolin is being produced and orthosilicic acid is being produced or silicic acid is being produced with liberation of potassium. Similarly, the albides, they liberate sodium with formation of kaolinite and silicic acid. The silicic acid further attacks the other reaction minerals. Similarly, olivine on hydrolysis, it produces magnesium hydroxide, then silicic acid, which are aqueous solutions. So hydrolysis is a type of ion exchange reaction where hydrogen ion in aqueous solution is exchanged with potassium ions in feldspars with which the aqueous solution is in contact. H plus ion in feldspar breaks its bond, weakens it and finally decomposes it. The potassium ion enters into the soil water. In warm, humid climatic condition, the soil waters are found to be having low pH and with rich hydrogen ion concentration, hence acidic, that helps in decomposition of feldspars into kaolin. So, this hydrolysis process produces kaolin. So, warm, humid climate is essential for decomposition of feldspars through hydrolysis and ion exchange reaction. Then oxidation. Oxidation, loss of electrons, oxidation, gain of electrons, reduction. So oxidation reaction, how it operates? It operates over the metallic minerals rich in iron, manganese, and it takes place in presence of moisture. It also acts over the sulfur rich minerals. For example, the red color of iron changes to brown and yellow on oxidation. Rusting is a type of oxidation. In case of iron, iron becomes weak by rusting. It breaks easily. So through oxidation, through reaction with water in presence of through reaction with oxygen in presence of water, the iron gets rusted. It becomes ilmenite. When oxides are placed in environment free from oxygen, reduction takes place. such as waterlogged ground, in stagnant water, below the water table, there occurs reduction. Red color of iron upon reduction turns into greenish or bluish grey. Olivine changes to hematite by this process. Let us say Fe2Si4, this is phyllite, a variety of olivine. On reaction with water, in presence of oxygen, it produces hematite and silicic acid. Similarly, rhodonite, with reaction with oxygen in presence of water, it produces manganese oxide. It may be pyrolusite and silicic acid. Here hematite and pyrolusite. So orthoclase, water plus carbon dioxide, it produces kaolinite, potassium carbonate and soluble silica. So this is the reaction. Olivines convert to magnesium carbonate and soluble silica. So this is the reaction. Silica is being produced. So other feldspar group of minerals on carbonation change to clay minerals and sodium carbonate with Na feldspars, or they convert into clay minerals or calcium bicarbonates from calcic plagioclases. So these are the products of the process of oxidation, reduction and carbonation that operates over the common silicates. Then solution or dissolution, or it is corrosion. This process is effective over carbonate rocks such as limestones and dolomites. The carbon dioxide mixes with water to produce carbonic acid, and this carbonic acid on reaction with limestones produce calcium bicarbonate, which is soluble, and because of which we find the formation of caves in limestone countries. As per the above reaction, calcium bicarbonate is being produced, and if evaporation will take place, then calcium bicarbonate will be converted into carbonate or limestones, as we find in limestone caves where the stalactites and stalagmites are being produced, a common feature in limestone country or in karst topographic features. So limestones with iron impurities on oxidation produce terra rosa, which is a common product found on the limestone surfaces, bright red in color, terra rosa. So limestone with iron impurities produce terra rosa. So these are the processes by which we find that the reaction takes place. In case of carbonation, the carbon dioxide plays a role. Carbon dioxide in presence of water, it plays a role to produce carbonates. So potassium hydroxide, which is produced in the hydrolysis stage of the orthoclase, this KOH reacts with carbon dioxide plus water to produce K2CO3 plus water, or this carbonates are being produced. The potassium carbonates are being produced because of its reaction with the carbon dioxide. So K2OH CO3, so H2O plus H2O, 2H2O. So the hydroxides produced through hydrolysis react with carbon dioxide and water to convert themselves into carbonates. So hydrolysis, hydration, carbonation, oxidation, solution, these are the chemical processes by which chemical weathering proceeds. And here it is to be said that this chemical weathering or mechanical weathering, they are not isolated processes. One helps the other. If we take into account that all chemical processes of weathering are independent, then the process will be very, very slow. As we have seen that the KOH is produced from orthoclase by hydrolysis, and this KOH takes part in carbonation reaction to produce potassium carbonate. Thus, it is seen that the chemical processes of weathering are quite interrelated, and all the processes of weathering are interrelated. One helps the other. They may exist independent, no doubt, but one helps the other so that the weathering process becomes more or less rapid. Otherwise, it would have been very slow process. Besides this chemical weathering, we have another type of weathering, that is mechanical, that is biological weathering. It is brought about by organisms. It may be brought about by plants. It may be animals, by organisms such as earthworm, termites, rodents. They are the burrowing organisms which bring fresh rock grains from deeper part of the ground to the surface, where they are further attacked by weathering process. Burrowing holes allow passage of moisture, water, air into the ground, inside into the ground, to speed up the weathering process. Similarly, human activity causes change on the ground surface through plowing, or man is responsible for disturbing the vegetation. The plants are being cut down, rock surfaces are made bare, so that mechanical weathering will be more effective. Or the rate of weathering is being controlled by these human activities. The low-lying areas produced by human activity become the site of more chemical weathering. So, through cultivation, fresh soils are brought to the surface for further attack by weathering process. So, man-made activities also aid and abet the process of weathering. Decaying plant matter produce humic acid, and that helps in degradation of the rocks and minerals. Plant roots grow through the cracks in the rock, and they widen the cracks. Moss, blue-green algae, bacteria, they affect the rock, collect nutrients from the rock by making the rock weak. The nutrients may be sodium, potassium, calcium, magnesium, iron, etc., which are liberated from the rocks by minerals through the above organisms and are used up by them for their growth and nutrition. By this process, the affected rocks become weak and breakable. They easily crumble to breaking process. And this organic decomposition is simply described as chelation. Chelates. Chelates are the organic hydrocarbon ring complexes produced directly by lichen and indirectly by the decay of plant materials to produce humus. Humic acid, it is acid. So this decay of organic materials, plant leaves, produces humus. And these organic molecules, they tend to bind metallic elements such as calcium, magnesium, aluminum, iron, ferrous iron, ferric iron, sodium, potassium. And these ions are released from the minerals through the action of this humus, where hydrogen ion enters into the bonds of the minerals, and these metallic components are removed from the minerals. They are brought into the solution. This process is called chelation. The metallic components are removed from the minerals through the humic acids. Thus, chelation involves exchange of hydrogen ion from chelating agent, that is humus, to the solution, and metal ions from this solution to the chelate or to this organic hydrocarbon ring. These metallic ions are brought from the minerals to the hydrocarbon ring. The increase in H plus ions decreases the pH of the solution and make them more acidic. The decrease in metal ions from the solution to chelate make the metal ions from minerals more soluble into the solution. Both processes tend to increase the decomposition of the metal bearing minerals significantly. The fact is that the humic acid produces H plus ions. This ion enters into the minerals containing the metallic elements. The metallic elements metals are liberated from the minerals. So minerals become weak. Minerals become weak. And these metallic ions, they enter into the organic solution. And so chelates become rich in rich in metals, and these metals are found to be available to the plants during their growth. So they support as the nutrients for the growth of plants. So in this process, because of removal of these metallic ions from the bond of the minerals become weak and they become more susceptible to chemical weathering because of the liberation of these metallic ions through their action with the organic product or humic acids. This is described as chelation. Through chelation, the minerals become weak because the metallic components of the minerals are released into the chelate. And this process is called chelation. So plants undergo decay, produce the chelate, they provide H plus ion to the solution in the ground, make it acidic. So this affects the surrounding rocks, make them weak, leach their metallic elements into the soil water, and this soil water is available to the plants in their growth. So from soil water to chelate and from the chelate to the plants for their nutrition. And so the metallic components from the chelate becomes less as they are being continuously used by the plants for the nutrition. It makes further attack to the minerals to liberate the metallic ions from the minerals, and minerals again come back to the chelate so that it is available to the plants for their growth. So during this process, more and more metallic ions are liberated from the minerals, as a result of which they become weak and they easily get affected by chemical weathering, and they become breakable and they are converted into fine grains. The ultimate process, the ultimate aim of weathering is to produce fine soil. And so by this process, the rocks and minerals, they crumble to the organic decay, and finally they lose rock matter is being produced out of this chelation process. So organic activity also indirectly affects the decomposition rate. What is that? The respiration produces carbon dioxide. Plants, through respiration, they produce carbon dioxide. This carbon dioxide combines with atmospheric water to form weak carbonic acid. This acid dissociates to produce hydrogen ion and bicarbonate ion. This bicarbonate ion dissociates to liberate H plus ion and CO3 minus ions. Release of this more H plus ions make the soil water acidic. This acid spreads up chemical decay of rocks and minerals. So, organic activity also indirectly affects the decomposition process besides chelation. And here is the mineral series that are arranged in and of their increasing stability. The halides, calcites, they are least stable, olivines, pyroxenes, calcic plagioclases, amphiboles, sodium plagioclases, biotite. So in this order the stability increases from the top to the bottom. Orthoclase, muscovite, clay minerals, zircon, rutile, tourmaline, quartz, then aluminum oxide which is gypsite, iron oxide, hematite. So in this manner the minerals are seen to be affected by weathering. As we go from the top to bottom, the stability increases. So generally it is found that quartz is the stable product of the silicates. That's why we find that the sand is a common feature or quartz is a common feature in the beaches, in the sea coast. It is the most resistant mineral to weathering. And if we take into account the Bowens reaction series, actually it is this series that accounts for the mineral resistance, that shows how the minerals are resistive to breaking. It is also called as Gold-Leach series. Olivines, pyroxenes, amphiboles, biotite. So, olivine is more breakable than pyroxene. Pyroxene more breakable than hornblende. Hornblende is more breakable than biotite. Similarly, anorthite is more breakable than labradorite. And similarly, as you go down, albites become more stable than anorthite. And we see orthoclase is more stable than albite, muscovite more stable than orthoclase, and finally the most stable mineral is quartz. So quartz is the end product of the weathering. So that's why soil is found to be rich with silica, this quartz. And let us have a look at the products of weathering. Quartz produces quartz grains and it produces silica in solution. Feldspars, they produce clay minerals. Silica, potassium, sodium, calcium ions are being produced in solution. Hornblende, it produces clay minerals, limonite and hematite, and produces silica, calcium, magnesium in solution. Olivine, it produces limonite, hematite, the final product of olivine, and it gives rise to silica, magnesium in solution. So these are the products of weathering. Then what are the main products of weathering? Let us discuss. Main product of weathering is, or the end product of weathering is soil formation. The top part of the regolith that supports the vegetation is the soil. Regolith is bit coarser. Soil plus alluvium plus rock fragments, they are the regolith. So soil grades to regolith as you go down. And unaltered rock fragments, still if we go down we find the unaltered rock fragments and minerals as residues resisting weathering. These are called resistates. If we see from the top surface as you go down, there is a depth up to which weathering can proceed. This zone is called this front is called the weathering front, or the depth up to which weathering proceeds is called the weathering front. This is weathering front. And this zone is the weathered zone. This is weathered zone. So, soil is found on the top surface, soil. Then regolith, then rock fragments, then undecomposed rock, which is called as registrates. This is registrates. This has not been affected by weathering, registrates. So, deeper rocks are called registrates. Then, what is the product of weathering? The soluble salts. Salts are produced. Then weathering pits, carene, which is the chemical weathering shown by the limestones, tors, which are found in granitic country, the residual blocks of granitic rocks resting one over the other, very common feature in Keonjhar area. We find the rock types presenting this type of arrangement. Actually, these are jointed rocks. Jointed rocks. See, they have been affected by chemical weathering like this. This has been affected by chemical weathering. So, therefore, this is called tor, generally presented by the granitic country. Then we find the formation of spheroidal boulders. Spheroidal boulders, exfoliation domes. Domes are rounded bodies. Domes are rounded bodies. So through exfoliation, the surface becomes smooth and rounded. Exfoliation domes. And it is seen that the rocks are highly strained. Strained rocks are produced. Denser minerals break to produce simpler minerals or less dense minerals. This is the product of weathering. Differential weathering leads to formation of waterfalls. Waterfalls are the results of differential weathering. So these are some of the features, some of the products of weathering. Waterfalls. Then spheroidal boulders, spheroidal weathering pits, carene structure, tors, then registrates. Then the top product is soil. Tops. So these are the products. And what is the significance of weathering? It aids in mass hosting erosion. If there would not have been any weathering, this mass hosting would not have been possible. Erosion, the process of erosion would have been difficult. Erosion is a process by which the earth materials are carried by the agents of denudation from one place to another. So, erosion is a process which involves weathering plus transport. So, weathering helps in mass hosting and erosion. It aids in differential weathering so that the waterfalls are being produced. It produces life supporting soil. It helps the formation of ores such as iron, magnesium, iron, manganese, aluminum, copper. Iron means goethite, limonite, then hematite, manganese pyrolusite, aluminum gypsite, copper sulfides. So these are the common products of weathering. It concentrates petroleum because it produces loose material, loose rock matter through which petroleum accumulates. It yields materials for construction of roads and buildings. It promotes biomes, biodiversity on the weathered ground. The development of forest cover is possible on the weathered ground. So, and as I have already discussed, weathering can not go indefinitely with depth. There is a certain depth up to which weathering can proceed. We cannot see weathering to be penetrating deeper into the earth. So the depth up to which weathering proceeds is called as the weathering front, and the zone that lies above the weathering is called the weathered zone. And this weathering front is found to be controlled by the climate, topography, rock composition, rock structure, rainfall. So all these factors that control to what extent weathering will proceed or up to what depth weathering can go. So, through weathering, we see that the rocks crumble, rocks produces a thick zone of loose rock matter, which is called the weathered zone, and below it we have the resistates, and this defines the weathering front. And because of this process, we find the life supporting formation of life supporting soil on the top, and that's why this process is highly useful in supporting life on the face of the earth, and we should take measures so that this weathered profile, weathered loose rock matter that accumulates on the top of the ground is not destroyed, is not wasted by any process. So we must take measures to protect this soil, because the formation of 1 centimeter of soil, it takes about 1000 years. So it is extremely slow process. Weathering is a extremely slow process. So this is all about weathering, and I think I have discussed this topic in a more systematic way, and my dear learners who are interested in geology, I think they may be benefited by this talk. So I thank you all for your patient hearing to this talk on weathering. Thank you all.